This is the second part, or the second series of questions based on the last video, which was 9 to 11. I'm now doing 12 through to 15. So this is an extension of that one, where before we just had a DC motor powering some lights. Now we've put in these transformers, and to make the transformers work, we've now got it in AC. That means everything is talked about in RMS. That's ready to go. A lot of people start timesing or dividing by root 2, but no, we want it in RMS, so we're just going to leave it as it is. No timesing or dividing by root 2. Alright, so same as before. The output's still, well, it's in RMS now, but the output here is 500 volts. It's stepped up by a 1 to 10 transformer. So it goes up by 10, comes along here, some of the voltage is used, and then it gets stepped down again by a transformer. So we divide by 10 there, and then we're left with some volts there. The current was the same as before, 20 amps to start with. As the voltage is stepped up by 10, the current is stepped down by 10. And so for current we get 2 amps in the wires, and the voltage is going to be 5,000 volts in the wires. So the question is, what is the RMS voltage will be at the input of the transmission lines at points X, Y at the alternator reading? So we've already done that. It's at that point there, 5,000. So that was pretty easy. 500, and then we times it by 10 to get the 5,000 volts RMS. 5,000. Alright, so I've just copied and pasted the picture over here. Just remember this was 500, goes up to 5,000, and 20 amps went down, divide by 10 to 2 amps. And this steps down, divide by 10. Alright, it says the primary of the step down transformer, this guy, the primary coil has 4,800 turns. How many turns are in the secondary winding? Well, it's a step down, so it's divide by 10. So this one's really quite easy. 4,800 divide by 10, there must be 480 turns. What is the power loss in the transmission lines now? Right, so power loss is the same as before, always the same formula, I squared R. Well, I squared R. The hard thing is getting the right I. Now a lot of people in this question use the 20 amps, but we know that once the voltage gets steps up by 10, the current gets stepped down by 10. So the 2 amps flowing along here. So what I've got to do now is put my 2 amps in. The same resistance as before when I was doing question 9 to 11. There's 2 lots of 5 ohms, there's 10 ohms total. And that equals 4 times 10 equals 40 watts. That's far less than, I think it was question 10 or 11 where we had 4,000 watts was lost in the power lines. This is the advantage of using transformers. Right, question 15, we've just got another page with a bit more room. Alright, I copied and pasted it again, so remember we've got 500 there, getting stepped up to 5,000 volts, 20 amps, getting stepped down to 2 amps, and they want to know what's the voltage at the output of the step down. So what's the voltage here? Give your answer to 3 second figures. Well, there's 2 ways that I'm going to run through to do this. Hopefully they give well, they will give the same answer, not hopefully. They will give the same answer. First way I'm going to do it is using power. So this, just like before, the total power that's given out by the diesel motor is VI 500 times 20, which we've done in a previous question, 10,000 watts. So 10,000 watts total minus, how much is used in question 14? We used 40 watts. So that means we have 9,960 watts left for the lights. P equals VI, so divide both sides by V, you get I equals P over V. Oh no, we want to find V, so yeah, P equals VI, divide both sides by I, yeah. V equals P over I, which equals 9960 divided by, what do we use, 20 amps, 2 amps? Well, 20 amps gets stepped up by 10, goes along here, and then steps down. The voltage steps down, the voltage goes divided by 10, so the current steps up. So back here we've got 20 amps again. So we use the 20 amps because that's what we want to find. That's it. We use the 20 amps because we're trying to find the voltage over on this side. 498, that one. The second way of doing it is to say, well, we start off with 500 volts. How much is left used up by the lights? By the power lines. So the voltage in the lines equals the current in the lines times the resistance of the lines. So current in the lines, remember, is 2, the resistance is 10, 20 volts is used up. In the lines there's a possible 5,000 volts to be used. 5,000 volts to be used. We use 20. The voltage before the step down transformer is now going to be 4,980 volts. So this is what we measure here. 4,980 volts. That gets stepped down by 10. Same answer.